right, so we decided today that we would do functions again. And all the questions that I'm doing with you are past paper questions. All right, so this is the sort of thing that you can expect that they would ask in your trials exams and certainly your final exams as well. Okay, so this question here, it says to us, the diagram below shows the hyperbola G defined by g of x equals 2 over x plus p plus q with asymptotes y equals 1 and x equals -1. The graph of G intersects the x-axis at t and the y-axis at 0 and 3. The line y equals x intersects the hyperbola in the first quadrant at S. Okay, so the straight line is the line y equals x, and the other function that's sketched there is G. I don't know if it's easy enough for you to see the questions. I don't know if those are big enough, but I was trying to sort of put the questions and the diagram on the page so that you would be able to see both at the same time. If it is difficult for you to see the questions, then let me know, but unfortunately then I'm going to have to go up and down and up and down and up and down, which is a bit irritating. But anyway, in 4.1 they want us to write down the values of P and Q. So very sort of typical first question. Okay, so you guys tell me what you think. Hello, Nick. What is the value? Q is the easy one. What is the value of Q in this case? What do you think, Matrix? What's the value of Q? Remember, Q is, this is what they mean by Q over there. I've highlighted it in yellow. There we go. Okay, so everybody says that Q is equal to 1. I quite agree with you. Lovely. What's P equal to? Right, so this is the one that we've got to be careful of. All right, so our vertical axis of symmetry, that is the line x equals -1. Okay, so in other words, the graph has been shifted 1 unit to the right-hand side. If we were talking about the brackets, what would be inside the brackets, of course, remember the sign changes round. So inside the brackets, we would have x plus p like that. So if we want to work out what the value of p is, all right, we would have to take that bracket and make it equal to 0. Okay, so in this case here, the value of p is going to be equal to, all right, whatever that was. Okay, so P is in fact equal to 1 in this case. All right, but because we want +1 inside the bracket. Okay, so P is equal to 1. So those of you that said 1, that is correct. Well done. Okay, x equals -1 is the equation of the asymptote, the vertical asymptote. All right, 4.2, let's do the next question. Calculate the coordinates of T. So what does T represent? Matrix, here's T down here. T is the what? Aha, quite right, Amanda. It's the x-intercept of G. Lovely. Okay, so lovely intercausal. Well done. Okay, so I'm going to let you guys do that by yourselves. Okay, so remember, for the x coordinate of any function, the rule is we have to let y be 1. Okay, so I'm going to let you do that on your own, and then you can tell me what the coordinates at T are. Yes, so we're going to let y be equal to 0. Yes, Yakupa? For the x-intercept, we're going to let y be 0. Nick, it can't be 2 because t is a point on the negative x-axis. So I would expect an answer, well, like -2 or -3 or something like that. That's fine. Okay, so Tsavu says the coordinates are -3 and 0. What are the rest of us getting? Let's have a look. So a whole bunch of you put answers there. Absolutely. Okay, so -3 and 0 is perfect. Well done. That's really good. Okay. I'm just going to quickly do that, and then we can talk about what the answer to the next question is. All right. So very good, everybody. We were supposed to take y, make it equal to 0, and that's going to be equal to 2 over x plus 1 plus 1. And then when we take this plus 1 over to the other side, of course, it has to change its sign. And then we can cross multiply, and we're going to end up with -x minus 1 is equal to 2. And then, of course, we want to take x over to the other side, 2 over to this side, and that's where we would get the -3 from. Okay, so lovely. Well done. That's perfect. Okay, so that's 4 out of 4. Let's have a look at question 4.3. So now they want us to write down the equation of the vertical asymptote of the graph of h if h of x equals g of x plus 5. So what are they asking us to do here? Yeah, does that make sense now, Ntokozo, with the signs? All right, so they want us to write down the equation of the vertical asymptote of the graph of h if h of x equals g of x plus 5. So what does that mean for us, Matrix? What are they telling us to do here? How are we expected to transform g of x? H of x equals g of x plus 5. What are they asking us to do? They don't want us to find the equation of the graph, Nick. They want us to find the equation of the vertical asymptote. So, Cassandra, does it mean that we add 5 to the x of h? No. In order to get the axis of symmetry, the equation of the vertical asymptote, g of x plus 5 is an instruction to shift g 5 units to the what, left or right? What does this mean? Okay, it means, hang on a second. It means shift G 5 units right. Okay, but we do that by subtracting 5. Okay, so we do this by subtracting 5. Okay. So in other words, our current vertical asymptote is the line x equals -1. If we want to move this graph 5 units to the right, we would need to subtract 5. Okay, not add 5. Does that make sense to everybody? So in other words, it's going to end up being, yeah, so G, sorry, I'm just getting lost in my own thoughts here. H of x equals G of x plus 5. So yes, so they want us to shift it 5 units to the right-hand side. That's an instruction to move it to the right, because they want us to plus 5. How do we do that? We take 5 away, then it's going to end up being, which would give us -6, which means, no, but then it would be 6 units. -6. Why am I just being stupid with this? G of x plus 5 is an instruction to shift it 5 units to the right. Sorry, I don't know. I'm just being really dumb here. Neliswa. It does. G of x plus 5 means shifted 5 units to the right-hand side. So we would shift it to the right by subtracting, because we've got to do the opposite sign. So if we are sitting at -1 and we want to move it 5 units to the right, we've got to take away 5. So this would be the line x equals -6. Let's just have a look at what you guys are saying. Shift G to the left by 5 units. No, so G plus 5 means shift it to the right. But if we're going to shift it, if we shift it to the right, it means we have to subtract. We've got to do the opposite, because the line x equals -6 means
we don't subtract.
No, hang on a second. If you were going to sub into the equation, then you would have to do that. Sorry, so it must be x, it must be plus 5. Sorry, that would be if we were working into the equation. Sorry, guys. So if we're shifting G 5 units to the right-hand side, it means we need to add 5 to that, which means we would end up with x equals, no. Neliswa?
Yes.
Am I being a monkey here?
Okay. If we, because
it's so they want you to shift it 5 units to the right. So it's currently sitting at x equals -1. So if we want to move it to the right-hand side, the thing is that now if it sits at x equals 4,
it makes sense if x equal to 4, because we're
yes,
going to move
it
it 5 times to the right.
Yeah, it does. Okay, all right. So this is it. Okay, this is the correct answer. Sorry, I don't know what was wrong with me there. I was just like, ugh. Okay, so yes, we've moved it 5 units to the right-hand side from -1, adding 5 to go to the right, and then we would end up with the line x equals 4. Quite right. Okay. To me, if we wanted to sub into the equation, so let's say they wanted us to work out, let's say k of x, and with k of x, we've shifted it 5 units to the left-hand side. Then what we would have to do is inside here, where we have our x plus 1, there, if we wanted to shift it 5 units to the right-hand side, then we would have to -5 like that. Okay, so when we're subbing into the equation. All right, but here it's a vertical line. So it's a vertical line that's going to be moved 5 units to the right. So it makes sense that it would be 4. Okay. All right. Sorry, guys. I don't know what happened to my brain there, but it went on blink. Okay. So 4.4, calculate the length of OS. All right. So that is this line over here. Okay. So there are a couple of ways in which we can answer this question. One of the ways that we can answer it, because they're asking us to calculate the length of a line, it means we can use distance formula, okay, which is not something that we would generally tend to think of in paper 1, but absolutely we can do that. All right, so if we decide that we're going to use distance formula, what it means is that we're going to need coordinates. So we know that at the origin, the coordinates are 0 and 0, but it means we're going to need the coordinates at S as well, all right? So how are we going to work out the coordinates at S? What does S represent for us? So not midpoint formula, Maya. If you look at the diagram, look at S. S is a point of intersection. Absolutely. Okay, so when we have a point of intersection, it means that we need to, exactly, Cassandra, 100%. We can equate them, quite right. Good, perfect. Okay, so we know that the equation of our hyperbola, it is the line 2 over x plus 1 plus 1. Let me just double check that that's correct. Yes, indeed. Okay, and our line that we're equating it to, it's the line y equals x. Remember, they told us here, let's just go and highlight that for you again. Over here, the line y equals s intersects the hyperbola in the first quadrant at s. Okay, so that means that we need to take 2 over x plus 1 plus 1, and we need to make it equal to x. Okay, so that's the first step. What we can do here, I mean, there's a few different ways to be able to solve this, but what I would do is this, is I would leave the 2 over x plus 1 on the left and take this plus 1 over to the right, and here we've got x minus 1, and that's of course over 1. And then here I would cross multiply. Okay, so cross multiplying. So this is going to give us 1 times 2 is 2. And on this side, we've got x minus 1 multiplied by x plus 1. Let's move this down. Sorry, guys. Just move this down. And that doesn't want to... Sorry, sometimes my mouse goes funny and then it doesn't want to work.
Cox.
Oh, no, still not. Okay, all right, that's fine. We'll just have to make a plan. All right, so now multiplying out our brackets, we're going to end up with x squared plus x minus 1. So because this is quadratic, we want to get everything onto one side and make it equal to 0. So that's going to be x squared plus x minus x. And then we're going to have to say minus 3, like so. All right, which means, sorry, coming up here, that x squared is going to be equal to 3. So x is going to be plus or minus root 3. But since s is a point in the first quadrant, it means that x has to be equal to positive root 3. Is that making sense to everybody? Yeah, Cooper, when do you change the equal sign to multiplication? You cross multiplying. Okay, so you're multiplying the denominator with the numerator and the denominator with the numerator. It's the same as multiplying by the denominator on both sides. Okay, it's cross multiplication. Okay, all right, everybody. Oh, hang on a second. I was going to say everybody's fine. Okay, so Kanyisa, if we go and look at the picture again, remember S is a point in the first quadrant. Okay, so it's what I highlighted in blue for you up here. Okay, no problem. Okay, so that's why we're choosing positive root 3 as our answer and not negative. All right, so we're getting there. So now at S, the coordinates are positive root 3. And since this is the line x equals y, then the y coordinate also has to be positive root 3. Does that make sense to everyone? Yes, to me, quite right. Quite right. Okay, so I'm just going to get rid of this. Okay, now, distance formula. Okay, so remember to calculate the distance of a line, it's the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so this is what we're going to have to sub into. So x2, we could make that root 3 minus 0 squared, and then y2, so that would be x2 and y2, and that would be x1 and y1. So we've got root 3 minus 0 plus root 3 minus 0, like so. Okay, so that is going to give us root 3 squared, so that will be 3 plus 3, so we're going to end up with the square root of 6. Okay, and that's going to be the distance of OS. All right, so therefore OS is equal to root 6. Okay. Okay, where did I lose you, Nick? Okay. Yes, so Luyanda, all right, remember this straight line is the line y equals x. So at S, whatever the x coordinate is, the y coordinate has to be the same thing. Okay, remember up here they told us it's the line y equals x. Does that make sense? Okay, there we go. All right, so we're nearly done with this question. We've just got one more question to do. You got root 6. Yes, me too. I also got root 6. Okay, as the distance of OS. I suppose the other way we could do it is we could do it using the theorem of Pythagoras, because we would also, if we know, well, mind you, then if we know what the coordinates at S are, so we know that this is root 3 and we know that that's root 3. So we could say OS squared equals root 3 squared plus root 3 squared. That would be another way we could do it. All right, so that means that OS would be equal to, OS squared would be equal to 3 plus 3. So again, we would get OS squared is equal to 6, and that's why OS would be equal to root 6. So that would be another way that you could do it if you didn't want to sub into the distance formula. Okay. All right, let's have a look at this last question. And it says to us here, for which values of k will the line g of x equals x plus k have real roots that are of opposite signs? Okay, so what does the letter k in g of x equals x plus k, what does it represent? What does this k represent? Can anybody tell me what the k represents? Okay, so if you've got the equation of any straight line, like let's say if I say to you, here we have a line, it's the line y equals x plus 3. What does that 3 represent? Yeah, absolutely, C, all right? So exactly, it's C, all right? So C is the what of the line? The y-intercept, exactly. Exactly, it's the y-intercept, all right? So in other words here, k is the y-intercept of this line, all right? So now if I have a line, this is the line y equals x plus k, all right? So maybe what I could do here is just make its gradient a little bit more in line with the other one. So here's the line y equals x plus k, all right? So it can sit on top of the line y equals x if k is equal to 0, and I can move it up, and then k is a positive number. And if I want to, I can also move it down, and then k is a negative number. Does that make sense to you? Right, so here's this line, right? So they want two real roots that are of opposite sign, okay? So in other words, one root has to be where it's negative, and the other root has got to be where x is positive, okay? So at the moment, it's got two real roots of opposite sign when it is sitting where it is currently, okay? So in that position over there, over the line y equals x. If we continue to move it down, what's going to happen? Is there any way for g to pass through the line x equals -1? It never will. So g is going to continue all the way down here, and it's going to get closer and closer and closer and closer, but it's never going to touch. All right. So for as long as we pull this line down, it's going to have one place where it's negative and one place where it's positive. So the place where it's negative is over here. The positive root is this one over here. Okay, so in other words, we've got a negative x value and we've got a positive x value. If we continue to move the line in the opposite direction, so now in other words, we move it up this way, just grab hold of it and move it up this way, I've still got one positive root and one negative root at the moment, okay? So where it's sitting over here, if I was to measure the value of x over here, it would be a negative number. If I was to measure the value of x over there, it would be a negative number. So what I'm going to do is I'm going to continue to push my line in this direction. Once I get to this point here, all right, I now have one root that is negative. That's this one here. And another root that is equal to 0. If I continue to go in this direction, if I lift it just a little bit more like that, now I've got two negative roots. Okay, two negative roots, because if I was to work out the value of x over here, it would be negative. And if I was to work out the value of x over there, it would also be negative. So in other words, I cannot go past this point over here, because if I go past where x is equal to 0 and y is equal to 3, I'm not going to have two roots that are of opposite sign, I'm going to have two roots that are the same sign, and both will be negative. Does that make sense to everybody? Okay, so what I want to do is I can't let my line go any higher than 3. All right, so it can be 3, that's the most it can be, and it can be anything that is smaller than 3. It also can't be equal to 3 because then I have one root that's 0 and another root that is negative. So I want a positive root and a negative root. Right, so in other words, my y-intercept has to be a number. So k has to be a number that is smaller than 3. Okay. Okay. This is only out of 1 mark. Okay, this is a difficult application type question, and it's not the sort of thing that we really need to worry about. It's 1 mark. As long as we can do the other things, then we're okay. All right, shall we move on to the next question? Okay, don't worry about question 4.5 then. Okay, it's only worth 1 mark. All right, so at this stage of the game, it's not something I think we should worry about. Okay, let's go and have a look at the next question. So here they have given us the graph of f of x equals minus x minus 3 squared plus 25, and g of x is the graph of 2 times 1 over 2 to the x plus 1 minus 4. So what sort of graph is f of x? What sort of graph is f of x? Lovely. Okay, it's a parabola. Good. All right, it's a parabola. And what sort of graph is g of x? It's an exponential function. Good. All right. So what they've given us here, good, everybody. What they've given us here is a combination of the two. All right. So we've got a parabola and an exponential function mixed together. What do they tell us about these graphs? Well, graph F, the parabola, cuts the x-axis at A and at C. So those are its x-intercepts, and the y-axis at E, and it has a turning point that they've called D. Graph G cuts the x-axis at A and the y-axis at B. Okay, let's have a look at the sorts of questions that they want us to answer. First things first, write down the equation of the asymptote of G. Okay, so because it's an exponential function, it means it has a horizontal asymptote. Okay, so what's going to be the equation of the asymptote of G? It's going to be the line y equals what? There we go. Good, to me, quite right. It's going to be the line y equals -4. Good job. Lovely. Okay, so because they wanted the equation of the asymptote, don't forget to write y equals. If you just write -4, you're not going to get that mark, okay? So you must make sure that you write y equals -4. Question 6.2. All right, what do they want us to do? Write down the coordinates of D. All right, I'm going to let you guys do that. Write down the coordinates of D, and then you can share your answer in the chat. What are the coordinates at D? Yep, the turning point, quite right. Anyone got the coordinates at D? There we go, Maya, well done. That's lovely. Yes, Luyanda, good. Yes, Ntebogen, nice. Yes, so the graph can't touch its intercept. Okay. So remember, the equation of an exponential function is in the form y equals ab to the x plus p plus q. Okay, and the line y equals q is the equation of the horizontal asymptote. Okay, so that's why it has to be y equals -4. Good. Okay, 3 and 25. Yes, lovely. So you got that from the equation. The graph has been shifted 3 units to the right and 25 units up. So lovely. Well done. The coordinates at D are 3 and 25. Good. Now they want us to write down the range of f matrix. The range of f. Again, you can write that down and then pop your answer into the chat. What is the range of f? Yeah, range is y, quite right. So your set of y values. What is the range of f? Amanda, you're quite right, but you can't just write 25. Okay, so yes. Tumi, you on the right track. Maya, you on the right track. Just make sure you've got to include the 25. Okay. So yes, what you would have done here is you would have said y is smaller than or equal to 25. Or if you want to write it with interval notation, round bracket, -infinity, up to 25, and then a square bracket. Okay, yes, y is an element of the real numbers. Quite right it is. Okay, good job. Let's go and see what they want us to do next. All right, they want us to calculate the length of EB. EB. So what does EB represent? Here's EB over here. There's E. There's B. Whoopsie. What kind of straight line is that? Terrible straight line. Okay, what does EB represent? Absolutely. So the y-intercepts, the difference in the y-intercepts. Quite right. Quite right. So how are we going to find the y-intercept of f? How are we going to find the y-intercept of f matrix? What would we need to do? Make x equal to 0. Yes, I like that idea. Okay, absolutely. So we're going to make x equal to 0. All right, so now we've got y equals -0 minus 3 squared plus 25. Okay, so this is equal to, that would be -9 plus 25. So the answer would be 16. So at E, the coordinates are 0 and 16. At B, how are we going to find the y-intercept? Okay, so again, we're going to let x be equal to 0. So here we've got y equals 2 times 1 over 2 to the 0 plus 1 minus 4. Okay, so a half to the 1 is a half, 2 times a half is 1, and 1 minus 4 would leave us with -3. Okay, so EB is 16 minus -3, which gives us 19 units. Okay, is that all right with everybody? Are we feeling good so far? Oh, good, Timna. Good. Good, Kanisa. Good, Kelebohile. I'm glad to hear it. Okay, let's go and see what the next question is. Okay, good, Silindile. Nice to me. Cool, Yakupa. All right, determine the values of x for which f is decreasing. Okay, so for good Nawazi, I'm glad. Okay, so for what values of x is f a decreasing function? What does the word decreasing mean when we talk about functions, Matrix? What does the word decreasing mean specifically for us when we're talking about functions? Okay, but decreasing means something to do with gradient. It doesn't mean that y is negative. Okay, it means that the gradient is negative. Absolutely, that's it, Sapiso. Okay, so it's where the graph decreases, it's where the gradient is negative. Okay, so where is the graph decreasing? Okay, where is the gradient negative? So from what point are you now starting to walk downhill? When do you start walking? You've been walking uphill if you walk from A to E, but at what point do you now start walking downhill? Quite right, where the gradient is negative. So when do we start walking downhill? Absolutely, when we're going from D to C and beyond. Okay, so D is the point at which we stop going uphill and we start going downhill. Remember, the x coordinate at D was 3. So the values of x for which this is now a decreasing function is going to be when x is a number that is bigger than 3. Does that make sense to everybody? Quite right. So D to C and beyond. Does that make sense where x is greater than 3? Good. Good. Okay. All right. That's fine. Okay. So Palesa and Tumi and Slindile, you don't know. Okay. No problem. All right. So a parabola that is shaped the way that this one is, if you were to be anywhere where the yellow line is now, where I'm drawing the yellow, if you were to be standing here or walking in this direction up there, you'd be walking uphill, wouldn't you? Okay, so what we would do here is we would say that the gradient is positive. So in other words, the function is increasing. Right, so as x is getting bigger, y is getting bigger. Once we get to D, we're not walking up, but we're also not walking down. D is our turning point. So at D, our gradient is now equal to 0. Once we get past D, we're not walking uphill anymore. We're walking downhill. Okay, and we would continue to walk downhill to negative infinity and beyond. Okay, so now when we walk in that direction over there, we are walking downhill. Okay, so here your gradient is negative. And the graph is now decreasing. So the value of x, C-R-E-A-S, there we go, is decreasing. So over here, that's where it all changes. At D, the coordinates are 3 and 25. So the x coordinate, where the gradient changes from being increasing to decreasing, is here at 3. Okay, so when x is a number that's bigger than 3, so to the right of 3, then we are now going to be walking downhill. Gradient is negative. No, Luyanda, we would not include the 3. Okay. Yeah, no, we would not include the 3. Okay, because at 3, the gradient is not decreasing. Okay, gradient is equal to 0 because that's our turning point. Okay, so no, we wouldn't include 3 in this question. All right, the next thing that they want us to do is calculate the average gradient between points A and B. All right, now I've drawn all over this, but A is over here. Let me just rub that out. A is over here. Here's A, and here's B. There's B. Right, so when they want us to calculate the average gradient of a line, it's like we are connecting the two with a straight line and we're working out the gradient of that line. So in other words, we need the coordinates at A and the coordinates at B so that we can sub that into gradient formula. Okay, so what does point A represent? It is what? What is point A? Known to cause we don't have to find the derivative for this question. It's an x-intercept of f. Absolutely. X-intercept of f. Okay, so I'm going to let you guys do that. Work out what the x-intercepts of f are. What is the x-intercept of f? Well, there's 2, but we're going to pick the negative one for a, aren't we? So for the x-intercept, we've got to let y be equal to 0. Absolutely, Kamgelo. I'm going to stop there. I'll let you guys do the rest of it, and then you can tell me what you get as an answer. I agree. I also got -2. Well done. Very nice. Okay, good job, everybody. Yes, lovely. Now we got to work out the coordinates at B. Okay, do we know what the coordinates at B are? Oh, no, we don't. Sorry. Okay, work out the coordinates at B. Remember, B represents the y-intercept of the exponential function. So again, for the y-intercept, let x be equal to 0. So you guys go ahead and do that. I'm just going to finish this. All right, do you have an answer for the coordinate at B? Oh, yes, of course. That's why I'm having deja vu. Yes, 100%. Okay. So we worked out that, sorry, and I just rubbed that off the screen as well. Okay, yes, you're quite right. So at B, we know that the coordinates are 0 and -3. Absolutely. So now what we've got to do is we've got to go and sub that into our formula for gradient. Okay, so y is equal to, sorry, where's my head today? M is equal to y2 minus y1 over x2 minus x1. Okay, so that is going to give us -3 minus 0 over 0 minus -2. Okay, so that gives us -3 over 2. Okay, and that is the average gradient. Yes, Norwazi. Yes, Maya. You're quite right. We had, when we calculated the length of the EB, and where I've now worked out the coordinates at S, that's where that working was, and I'd rubbed it off. So that's why I was having deja vu, but I couldn't actually see what we'd done. Okay, well done, everybody. This is really good. Nice. Right, so let's just, I don't know if we're going to be able to do all of these questions, but let's just see what we can finish in the time that we have left. Okay, question 6.7. The graph T is obtained by reflecting G about the x-axis. Okay, so remember G is our exponential function. So they want to reflect it about the x-axis, right down the range of T. Okay, so if we take our exponential function and we reflect it over the x-axis, what's going to change sign? The y, absolutely. So y changes sign when we reflect over the x-axis, 100%. Okay, so I'm just going to rub this out over here. All right, so t of x is going to be, the y has to change sign. Okay, so this is y, remember? Okay, so it's going to change sign. So in other words, we're now going to end up with -2 times 1 over 2 to the power of x plus 1. All right, and then here, this would obviously have to change sign as well. So that would be +4. Okay, so that's what would happen to t of x. And they wanted us to write down the range of t. Okay, so now its asymptote is now the line y equals 4. So that's the equation of the asymptote of t. So its range is going to be any number that is smaller than 4. No, it won't affect the exponent. It affects the sign of the term. Okay, so this first term has changed sign and the second term has changed sign. No problem, Nick. Okay, and then here, if P of x is f of x plus 2, write down the coordinates of the turning point of P. So in other words, what we're doing to create P of x is that we're taking f of x and we're moving it 2 units up. Okay, so it's still going to be in the same place as far as left and right is concerned. It's just been moved 2 units up. So at D, what's going to change when we move it 2 units up? Exactly, we're going to do something to the 25. Can anybody tell me? So we're going to change the 25. The 3 is going to stay as the same because it's not moving left or right. And the 25 has got to go 2 up. Okay, so that means that it's going to 25 is going to become, yeah, there we go, Nick. It's going to become 27. Well done. Okay, so the coordinates, oh, got my pen the wrong way around here. Okay, so we've got the coordinates at the turning point are going to be 3 and 27. Good. Well done, everybody. Yes, Palesa. Yes, Amanda. Yes, Tumi. Not horizontal shift, Luyanda, vertical shift. Okay, so if they want us to move it horizontally, Luyanda, then they'll say f of x plus 2. That's a horizontal move. Okay, but f of x plus 2 means this is a move upwards. Okay.